So this is the implementation of the scoreboard, which is named as interconnect scoreboard, extending from the UVM scoreboard, and it is parameterized with AXI and OCP transactions. And also this request and response transactions are again type parameterized by using the type keyword, and this is to make the scoreboard more generic. If you don't want, you can omit this type parameterization. And in the scoreboard there is a request airport and a response airport. The request side transaction will be coming through the request airport, and the response side transaction will be coming through the response airport. So you have to create different instances of the scoreboard to make a comparison of the write and read transactions separately. And also there are two analysis before to supply the implementation of the final analysis export. And you can also see that there is a master ID field, and depending on the master ID field, we will wait till we are getting a relevant transaction in the FIFO. In the build phase, we are creating the read airport and write airport exports, and also we'll create the instances of the analysis FIFO. And finally in the connect phase, we are connecting the analysis FIFO implementation, which is analysis underscore export, to the export that we had declared here. And in the run phase task, in a for-hour loop, we will be waiting for a request transaction to come, and then you will wait for a response transactions to come in the response FIFO. Also, you know that there is only one OCP slave at the end. Thus the OCP slave airports will be always sending the mixed transactions, that is the transaction that is valid for ID from 0 to 7 and ID from 8 to 15. Thus here we are filtering out the valid response transactions by using the internal master ID. So if you are getting a response transaction with the ID greater than 7, and if the master is 0, then you should wait till a valid response transaction coming. And in the same way, for master ID 1, you should get a response transaction with ID between 8 and 15. Once you got a valid response and input request, you will be comparing these requests and response transaction by calling the compare or AXI-OCP function. So this is implementation here. In the AXI-OCP compare function, we are passing a simple message, and we are saying whether to compare data or not, and we will be passing the AXI, the request type, and the response type, or the AXI type and the OCP type. And if you are using the parameterization, type parameterization, you can cast and check whether they are valid. Otherwise, you can directly compare whether the input, if the AXI is a read and the OCP command is not read, or if AXI is right and OCP command is not right, then it's an error. Then you can say indicate that these transactions are mismatching from the read write field itself. And in the same way, you are comparing the individual fields in the AXI and OCP transactions and making a status string, whether if they are not equal, you are making an information in the status string from which field it is not matching. And after this checking, if still the status string is equal to EQ, that which is the value that we have initialized in the beginning of the function, we can make sure that the comparison is successful, and you are printing a information saying both are equal. And if they are not equal, you are flagging an error using the tick UVM error macro, saying that the transactions are not equal and they start differing from the status field. And also you will print the information regarding the AXI and OCP transaction using the AXI transaction to dot convert to string function, which we have implemented in the transaction class. Now you have written the scoreboard class. Finally, you are connecting all the two master agents and the OCP slave agent and the scoreboard using an environment class called interconnect env, which we will be seeing in the next session.